Welcome to this video tutorial involving graphing polar functions. Now, of course, graphing polar functions is going to be pretty cool, right? Bad pun and all. Well, the first thing that we're going to want to do is convert that equation into our typical yx form. So we're going to get y is equal to 2 minus 3 cosine of x. And we would like to draw this graph as we usually would. Let's get the basic graph of cosine on the screen. Here's the basic graph of cosine. We should all be good with the fact that it's 1, 0, negative 1, 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now if we want to graph this function, we would reflect it across the x-axis, vertically stretch it by a factor of 3, and slide it up 2. Since we're reflecting across the x, it's going to have this shape to it. And as we undergo those other transformations, we didn't do anything horizontally. So we'll still have 0, pi over 2, pi, 3 pi over 2, and 2 pi. But then, reflected across the x, as we follow this through, this would be a negative 1, this would be a positive 1. Then we're moving it up 2 after we multiply it by 3. So we'll have negative 3, positive 3, scooted up 2. Once it's all done, this should be a negative 1, 0, 5. So the highlighted equation, y equals 2 minus 3 cosine x, gives us the graph that we've highlighted in yellow. But that's not the graph we want. We want the graph of r equals 2 minus 3 cosine of theta. So we'll sketch some axes down here. And what we're going to do is follow this graph that we've already drawn. So first we're going to look at the blue highlighted portion, which notice it starts at theta equals 0 and a radius of negative 1. So theta equals 0, a radius of negative 1 would be that point right there. And it's going to go until we get to theta equals pi over 2, and we have a radius. Actually, let's fix this really quick. That's not a 0 there. Sorry about that. When we slide 0 up 2, it's going to go to 2. So this should be theta equals pi over 2 with a radius of 2. That puts us at this point right here. Remember, got to get used to the polar coordinates. Radius of 2 in the direction of pi over 2. Now, when we draw that in, initially, in this first part of the first quadrant between 0 and pi over 2, we are getting negative radius values. So if I picture negative radius values from a vertical angle standpoint, we're drawing right here to start things off. So when I draw the first part of our polar curve, we're going to get something that goes like this until it gets to r equals 0, somewhere at the origin along the way. And then it's going to continue until we get up to that point, like so. But the thing about polar coordinates and polar graphs is, more often than not, they draw in a nice circular pattern. So you could just draw that in one single motion. Let's go to the next portion of our graph here between pi over 2 and pi. So we're going to go from theta equals pi over 2, r equals 2, until we get to theta equals pi, radius equals 5. That's going to be over here, theta equals pi, radius equals 5, and the radius just keeps enlarging until we get to that point. Now you might be saying, well, how is the radius enlarging? Well, right here, when we have an angle close to pi over 2, the radius isn't that large. As we get an angle close to 3 pi over 4, the radius gets larger. And as we get an angle really close to pi, the radius gets even larger. Now let's turn our attention to the next portion of our graph. The next portion of our graph here goes from pi to 3 pi over 2. It's going to continue until we get to theta equals 3 pi over 2, and the radius equals 2. That's going to be a point down here. Theta equals 3 pi over 2, and the radius equals 2. And the radius just gets progressively smaller as we draw this in. Again, hopefully we see that the radius is getting progressively smaller. Here it starts large, here it's smaller, and over here it's even smaller. Then we have the last portion of our graph from 3 pi over 2 to 2 pi. Again, it picks up where we left off, and it's going to continue until we get to theta equals 2 pi, and the radius equals negative 1, which is back where we started, actually. And I claim on this portion it's going to pick up where we left off. It's going to go through the origin, and it's going to go back like that. So now why does it do that? And I guess I didn't go perfectly through the origin. Please try to draw it nicely and well. So it goes like that. Good, 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 good. So let's hopefully see that this works. Here, when we've got certain angles, close to 3 pi over 2, the radius is positive and it draws like so. But as we get closer to an angle of 2 pi, the radius gets negative. As we get closer to an angle of 2 pi, the radius gets negative, which is why it's being drawn backwards, and that's the graph we get. Please label those key points. So here this was 2 comma 3 pi over 2. Up here this was 2 comma pi over 2. Over here was 5 comma pi, and this point was negative 1 comma 0, or negative 1 comma 2 pi. That would be the graph of our polar equation, and we can double check it on the calculator. So when we're doing this on the calculator, make sure our mode is on polar, not function or parametric. We'll go to the y equals, we'll type in our equation of 2 minus 3 cosine of theta. We need to make sure that we're also in radian mode, and if we are, we should be able to graph it, and we should get the same picture. Now we might need to modify our window a little bit, so what if we went from an x-min of negative 5, that's where the graph ended, to an x-max maybe of 3? How about a y-min of negative 3 and a y-max of positive 3? I'm just looking at the graph that we have and deciding where the x and y window should fall. And there's the graph, and that's the same graph that we got. So polar equations, first graph the original function like we usually would, and then take each part of that one at a time to see how the graph will work out. And typically each part one at a time, watch for the key things of pi over 2, pi, 3 pi over 2, as that determines the quadrants in which you're graphing.